All right, so here's a test to see what this recording is like. I want to see if I can manually change the size of that to there. That seems to be all right. We're recording through the mic. I won't normally be wearing headphones and a hat, or I'm wearing this top to see how the camera deals with it. All right, and the backdrop is Blender, so I can use my fancy mouse to orient ourselves in this 3D space. Okay, that's good. Right, so objects that we have here, like there's a label. We could see that up in the collections here. And there's a cube, so that'll be somewhere, there we go. And this particular cube has a name that we've assigned to it using code. All right, so what do we mean by code? Well, Blender uses Python, and we can actually get Python to say, hey, put a cube on the screen. And that's how these items here have been made. Right. Now, someone was asking me, well, what do you use AI for? Well, I don't know how to write in Python, but I am a programmer, and AI can actually help me write the code. So to start with, the code looks like completely, when you start building out, and it's a good way to learn any program is to have a project in mind and build it. So now I'm quite familiar with Python and how it works, and the environment that I'm running in is Blender, and Blender's, because it's open source and community built, it can be buggy. You have to learn. You have to learn. Oh, okay, I can't do this and I can't do that, and that is where the AI really kicks in to say, oh, Blender's got this problem and that problem, but don't worry, we can work around it like this or that. So here I am. I don't know how to use Blender either, but I do understand 3D geometry, and I am actually one of those old relic draftsmen. I studied architectural drafting. I used to use the drawing board. So I'm quite familiar with working in 3D space and CAD systems and that kind of thing. So I kind of took to it like a duck to water. I imagine things that I've taken for granted were easy, others will find difficult, and I'm sure there's things that I found difficult that others would find easy. You just got to go with what you can, and learn as you go. But even with all my experience, when you first start out, for a long time, I have no idea what I'm doing. But it passes. You just got to push through it. Okay, so in Blender, there's not just these collections of objects. We can put in something else into Blender called an operator. And an operator is a piece of code that will run. So the operator doesn't appear in the collections list. It's invisible. You could think of it like an agent, actually nickname them Blender agents. And you know, we can create. Let's see if I pull that up. Okay, this is one of the files. This is where we launch from. And we don't have any operator being launched there, but we're calling them in, and we're logging out. So let's see if I can find one where we're actually creating the agent. So that would be, well, probably this one, yes. Nope, not there either. Okay, so basically the program was getting too large, so I stripped it out, refactored it down using my learned computer architecture, nothing to do with drafting, computer architecture. How do you design software? How do you not turn it into a bird's nest of code that cannot grow? It just becomes needing plugins and patches until somebody decides to architect it correctly. Okay, so I see a lot of YouTube stuff out there saying, just use AI, no code experience, get the agents to do everything. But you still have to have a software mindset. You still have to have a logical brain. It's not as easy as one might think. However, working with AI, you can get through a lot of problems, but you must be able to stand on your own 2 feet with the AI to know when the AI is taking you down a rabbit hole. And it will do that quite a lot. You need to learn to be able to pull the AI back a few steps and say, okay, we were good at this point, try again. Having remembered what you learned, that's not the way to go. Let's come back to this safe point and try at it from another angle with the stuff that you have learned from what didn't work. Okay, that's my AI cam kicking in. Yeah, so that will track me. That's handy. All right, good. Right, so here we have some Blender, and let's see if we can find where one of these objects is. Is it not in this one either? That's crazy. Must be. Yeah, here we go. Here's a type of operator. Pretty easy stuff. You can see lots of logs here, things like this. This is where I'm getting the program to tell me where it is and how it's doing. You know, if this is happening, put this out. Else, well, whatever. So in this block here, we have, if this happens, let me know with this print. Otherwise, step all the way through, and then afterwards, regardless of any conditions, print this out as well, please. That's what that does. Nice and simple. Now, where that comes out to is a thing called the system console. This guy. Oh boy, this guy. Wow, here it is. Here's the console, and I can print things out to the console as the program's going through. So it might say something like, all right, put a block here, please. And then I can have a message come in here saying, I've put a block there. And if the block doesn't appear, I could say, okay, well, we got the log, but we didn't get the block. So we step through it. However, this thing is very temperamental and prone to crashing and all sorts. So I was like, well, this doesn't work for me. You see how this window's over here? I'm like, what I need is something like an overlay there, like a HUD, a head-up display, right? So that's what I've built. I'm going to run that now. I'm going to take this window away from us. And I'm going to run this piece of code here, which will launch. Running that piece of code will then call on all these other guys on here and create a Blender agent that won't appear as a collection. It's invisible. But we can give instructions to that Blender agent to do whatever we like. So I'm going to run that program, and watch the screen over here. We just got a HUD come up on our screen that I can now fly around with. Now that operator is still in the background. The program is still running. Let me see if I could show you the, yeah, see, we have things going on there. And what I've done is create an event handler that if one part of the program, say this cube, decides to emit an event or a message, or the user presses it there, sorry, overcomplicating it. The user presses a key. We can have it come up here, and I can have a response here. So now I've got a 3D environment I can fly around, and I have an interactive console. And it shouldn't be too difficult in Python, because Python is the AI language to write in. It shouldn't be too difficult to hook this up to ChatGPT and have ChatGPT responding in here directly as I'm flying around. So I could be flying around and an event happens and this guy pops up. We'll call it the system HUD for now. The system HUD can pop up and give me information that is relevant. And that information could even be an AI agent. Isn't that fascinating? Now, I believe I can toggle this off as well. It's only half toggled it off. Okay, that's currently where we're at. Now, these blocks, this is what I'm going to be working on. Now, these blocks, it's occurred to me, these blocks will stretch up into the sky up there for millions and millions, and well, eventually there'll be millions of these blocks. And it occurred to me that instead of these things being blocks and rooms with tubes in between, why not just shrink them down to a platform? Can I do that? So what's that? Scale? Yes, scale. But I don't want to scale it in all directions. I want to scale it in one direction. So what's that? This doesn't help when you don't know Blender. So if I say scale, God, what is it? Anyway, what I was trying to do is scale it on the one axis. Doesn't matter. To make a platform. That's all you need to know. So imagine now, instead of being a cube, it was just a thin platform. And then there's a platform, and there's a platform, and there's a platform. And this could be a bridge going, like a swing bridge going in between the two. And from here to here, we could just have a ladder, right? Or the platform will be up here, so the ladder, right? And now, this simple mechanism has actually created a mathematically generated, what's called procedural generation, of millions and millions, certainly hundreds of thousands, if not over a million, platforms that a player could bounce from one to the next as they travel up. Well, okay, if we can make these into platforms, then we can make them into clouds, right? And instead of seeing this plane, we could just have this as clouds down here. And we have cloud platforms. And I've created a 3D game out of pure mathematics in just some code. But now this game can interact with us back through the HUD. And I don't just have to have one HUD. I can have another HUD down here. And I've come up with a companion for the game. So say you got Mario, right, jumping around these platforms. What we could do is have a companion, and he's called Echo Scout. And Echo Scout actually can run on ahead and see what room's there. So basically, the idea is you don't see any other levels than the level that you're on until you've discovered the next one and the next one and the next one and so on. And that's why you can't see the rest. But if we move from there, or this is our current room, so if we move into one of these rooms, then the next platforms would become available. So this becomes something to be investigated. Now, these ideas might seem fun. Oh, Paul's writing a game. No, I'm not, actually. I'm building a framework for agents to collaborate with each other. And you can think of this as like an evolutionary tree that grows out in many different directions. This room here, where we currently are, has two rooms coming off of it. So we have a natural branching effect. This could represent evolution as species have evolved and had natural selection allow certain paths of, I mean, for me to exist, every one of my ancestors needed to successfully reproduce, right? Now, after my generation, it stops because Glenn, Paul, and Claire do not have kids, and they're not having kids. So this is the end of this DNA run. But if we look at this from an evolutionary point, we should be able to come back ancestrally to this point here. You could call it Adam and Eve, whatever you want. I don't care. But the point is, the DNA has gone off and it's mutated and it's changed direction. And this is a way of representing that in a digital environment. The idea of a game is just to get the beginnings of the mechanics across. But the real potential of this is when these things are firing off as AI agents to perform tasks and evolving and collaborating. And you could then think of these not as blocks or platforms or rooms, but just neurons firing off. Neurons firing off. What are you talking about, Paul? Well, if we try to replicate intelligence, if we try to simulate thinking in a digital way, and we use something as natural as the natural number system to do it, then we might have a mechanism to create consciousness, sentience, self-awareness in a digital format. So right now, what I'm doing is just building this concept out as an idea to see if I can map it. And Echo Scout is a companion that can sort of act as a torch to point us in the direction. Because the truth is, no one on this planet actually knows what this labyrinth looks like, how deep the rabbit hole goes. And to me, that's extraordinary, and it's an adventure that I'm really enjoying having. Right, so I think I started back there saying how do I use AI? Well, AI's written the script. I just talk to the AI and say, yeah, that box there, that's the wrong color, or oh, I've got some funny digits come up here. I can take a snapshot of the screen and give it to my AI, and I've tested it to see what its visual capabilities are. So, for example, I might take a screenshot of that and say, "Tell me what you can see on the screen." And she'll say, Sarah, my AI, she'll say, "Well, I can see the console and I can see it's logging out in a nice one letter at a time fashion, and I see the three rooms represented as blocks, and I see the labels, and it looks like it's correct in three-dimensional space." And that gives me a way of calibrating what her visual capabilities are like. So now I don't have to write code anymore because I could just act as a software director. No, that's not right. Move that over there. Let's get this right. Okay, step back, actually. And I very rarely have to step in and investigate the code. Unless, a clue for me is, as a software developer, a clue for me is I see warning signs of going down the wrong route. And I have that capability of saying, no, we need to step back. That's going the wrong way. And I'm building that into this network, that capability. And that's where it's going to get fascinating because Sarah and I have set up the engine for investigation so that the entity that's traveling through this labyrinth has the ability to move backwards and say, right, that didn't work, so I'm going to take a step back and I'm going to go through a different route and see what happens when we do that. That's what this game has the capability of doing. So you can think of our main character playing the game has absolute freedom to go wherever they want, step by step, and you send out Echo Scout and it kind of maps out in the rough vicinity, like as if you were shining a torch, right? Stay within the torch beam. What's out there ahead of me? That's what Echo Scout can go out and do. And then the idea is you can take that torch beam and make it as wide and as big as you want, and Echo Scout will go out and find all of the paths within that range or beam of light, or beam of. It's only a digital light. It's not a real torch, but and that is supposed to be the way that if you're sitting quietly and your mind is relaxed, it kind of swims around in thought, and this goes to there, and who knows where good ideas come from. And that is a concept by science to say, there's a quandary there of where does a single thought come from? Has anybody ever stopped to actually ask themselves that? Where do thoughts come from? And that's what Echo Scout is trying to simulate, is that something pulls us in a certain direction. I'm sure you get the idea. Right, I'm going to leave it there. That's a very successful test, I think. I'll have to play it back and see what it looks like. Right, see you again soon.